Oh, great.
In this video, we are going to look at how to solve polynomials, specifically quadratics, using factoring. Now, if you're somebody who is really confused with factoring, I highly suggest you go back to some of my previous lectures and take a look at examples on how to solve how to factor polynomials using different methods. Here, we're going to look specifically at how to solve your polynomial. So that means we're going to use all the factoring methods that you would use previously, only here we're actually going to determine what x is. So as a reminder, we always have to start in your standard form, ax squared plus bx plus c. Now this is the same no matter what the degree level of your polynomial is. However, specifically here we are looking at the quadratic. Okay. Solve by factoring essentially means that you have to factor the formula completely and then set it equal to 0 to find the variable. Okay. So here, what we're first going to do is notice we have 40x squared minus 9 on one side of my equation and 64x minus 8x squared plus 3 on the other. So what we have to do is we need to take one entire side and we need to move it to the other side of my equation, thus setting the equation equal to 0. Okay, so here what we're doing is we are going to move all terms to the left side. Okay, so in this case I have 40x squared. I'm going to add 8x squared to it. It's going to turn this into 48x squared. My 64x is positive, so I'm going to have minus 64x. And then I have negative 9 minus 3, so this is a minus 12 equals 0. Once you have your equation set equal to 0, you're going to look at your equation here the same way we would if it was an expression. We want to look first to see if there are any common GCF terms in here that we could possibly divide out, and in this case we can. We can pull out a 4, and that's going to leave us with a 12x squared minus a 16x minus 3 equals 0. Now the difference is here I can divide this entire equation by 4, thus making it go away. So here we only have 12x squared minus the 16x minus 3 equals 0. Okay. From here we have to go ahead and factor. Now in this case, because my x squared term has a number that is drastically greater than 1, I would go ahead and use the bottoms up AC method, which that says we're going to take a times c. So this is going to be 12 times a negative 3, which in this case gives us a negative 36. Now I want to look at all of my factors of 36 that when combined together give me 16. Okay, so in this case we know that 2 and 18 give me 36. I want a negative 16, so if my 2 is positive and my 18 is negative, I get that. So I'm going to set up my factors to have x plus or minus your factor over a, and we're going to multiply that by the secondary factor. So in this case my two factors are positive 2 and negative 18. So this is going to be x, then I'm going to have a plus, and I'm going to end up with 2 over 12, and x minus 18 over 12. The next thing I need to do is I need to reduce these fractions. So here this is going to be x plus 1 over 6 and x minus 3 over 2. Remember, this is still equal to 0. Your bottoms up AC method says take whatever is in the denominator and make it become the coefficient to your x term, and you're going to do that for both of your factors. So here we're going to end up with a 6x plus 1 times 2x minus 3, and this equals 0. Now normally this is where we would stop if we were factoring, but in this case we're trying to solve. So solving says we're going to take each factor, so 6x plus 1 equals 0, and 2x minus 3 equals 0. Now from here what we have to do is we have to finish solving the problem. So here we have the 6x plus 1 equals 0. We've got to get x by itself. So 6x equals negative 1. So x equals negative 1 over 6. On the other one we had 2x minus 3 equals 0. So again, the 2x equals 3. So x equals 3 halves. So in this case, what we're looking at is we have two solutions. In this case, we have that x equals negative 1/6 and x equals 3 halves. Okay. Now with this, once you figure out what your solutions are, you can plug them back in and check your work. Now you would plug it into the equation you use. So we would come back here and plug them in here to be able to make sure and verify that they give you what you want. Alright, let's go ahead and take a look just at one more example here. So in this case, again, I have terms both on the left and right. I want to try and do everything I can to make sure that my square term is positive. So I would take all of my terms on this right side and I would move them all to the left. So here this is a negative 20. So to move it says I add. 20 minus 5 is going to give you a 15x squared. I'm going to take my positive 2x and move it, so this becomes minus a 3x. 4 minus 4 means it goes away, so this equals 0. Now if I look at this, notice I have terms that are in common with each other. So in this case, not only can I pull out a 3, but I can pull out an x. In doing so, that leaves behind a 5x minus 1 equals 0. Now I have two terms here. I have this first term and I have my second term. Okay, so this is term 1 and this one is term 2. I have to solve both of them. So here we would end up with 3x equals 0, so x equals 0, and then we would have 5x minus 1 equals 0. The 5x equals 1, so x is 1/5. Okay. So here again we have two solutions, and those solutions are that x equals 0 and x equals 1/5. So in a nutshell, that is what we need to look at in terms of being able to solve quadratic equations by factoring. So if you remember, the goal is to factor it by any means necessary, either by greatest common factors or by using, say, that AC bottoms-up method. And then the only difference is once you factor, make sure you continue to solve in order to determine what your values are. So if you have any questions, please let me know. Otherwise, I do hope you enjoyed this video, and I will talk and see you next time.